Yeah, and of course the fun part. Don't wait until the end. We'll have a quiz about container level migration, and we'll give it away some cool swag and AirPods for free. Yeah, Kunal.
Yeah. And the question will be from only this presentation. And so if you stick to the end, we'll ask some cool question and definitely you can win.
Hello everyone. I think I have joined the party little late. So
Nice.
I didn't know we were live. I thought we were just on the pre-screen. But looks like we are live and looks like we have already started. So I'm not sure, Kunal, what we have discussed so far, but I'll just brief the audience about what to expect from here and then you can take it from there, right?
Sure.
So if you have registered for this webinar, so over here we have Vyotas and Kunal Das from CastAI, and they'll be showing us an end-to-end demo of container live migration in Kubernetes with the help of a real-time Minecraft server. If you have registered for the webinar, there is a chance to win AirPods Pro 3 and some cool swags from CastAI. And rest Kunal will take you with the agenda and what we'll be discussing today. You can ask your questions and we'll have some Q&A session at the end as well where you can go and ask your questions. Kunal, over to you. Thanks for joining, by the way. Thanks everyone for joining.
Yeah, no worries. And people who are watching on video, they can also, if they want to participate in our webinar or the giveaway. I'll ping the link, Piyush, if you can share with your followers on YouTube as well. So whoever wants to join the webinar directly, we'll do some giveaways and feel free to join in. And so we'll share all the codes and all the quiz questions, and definitely you can win. So yeah, that's about it. I think today what we are talking about use is something very game changing, I would say. And since guys who are watching that, I was checking out before you joined, what is the average experience. So it seems like everyone here is more than 2 years, 4 years, 5 years, someone 7 years experience in Kubernetes. So that's a lot. So thinking from that angle, I think live migration, there are a lot of problems, what it solves, how we're doing it, and definitely we're gonna show a demo. So that's what it is all about. So firstly, before we dive into what is live migration and all, gonna just go ahead and introduce CastAI to certain audiences. So CastAI is basically a Kubernetes optimization platform, and what it does is it optimizes your cluster. That being said, it only optimizes if you are working on-prem, AWS, GCP, Azure. It's completely cloud agnostic. And what we do is in your cluster, we install a small agent that will optimize your resources for memory, for CPU, and all the stuffs, right? So that's what we basically do at very core, and we run certain algorithms to schedule pods to certain nodes. We identify spot instance, which is very cheaper, almost like 90% cheaper than normal instance, and we schedule pods there. We move pod across different nodes, different workload, and it's not only observability platform, but on top of that, it acts automatically. So that's what we do. And automation is the key ingredient. When I say that, I mean that rather than doing manually. So when we are working in any cluster, the main problem that comes to our mind is, okay, what kind of node do I use, or what kind of size of node do I use, or what request, what limit to give on any pod. That sometimes becomes a problem, because hardly anytime we check every 30 minutes or every 1 hour if my application is sufficiently behaving, if it's undersized or oversized. So that we take care. So we check your application, we check your pod if it's correctly correctly assign the numbers, and we bin pack the pods into a single node. And on top of that, we heavily use spot instance, which is a great way to reduce cost, but it's a little bit complex because it can get evicted. So that's when we use spot that will not only uh, reduce your cloud bill to a great extent, but on top of that, it will also make your cloud bill less. And by using CastAI, you don't have to manage all the hassle of what if my spot goes wrong, what will happen, what not. So that's what at core it is. So before we dive in, like Piyush, maybe we can wait on this slide and a little bit discuss like what do you think, like you have also worked with multiple clients, and you have might have worked with multiple different cluster in different enterprises. Have you seen this thing, right? Whether any cluster, or when a cluster is manually managed, if it's like fully optimized, or what have you seen? What's your experience on that?
As per my experience, what I've seen is cost optimization is the biggest issue that any organization could face or these days. Most of that the workload that they have deployed, it's not fully optimized for the Kubernetes cluster that they are using. Sometimes the nodes are underutilized. Sometimes they run into issues because of the overutilization of nodes and the resources, right? And there is no, what I see is missing is there is no predefined checklist or formula that we can use to uh, predetermine the resources that your workload will need. So it's mostly try and test it. It's mostly like how it works in the lower environment based on the results from performance testing and so on. So that's the biggest bottleneck these days when it comes to running your workloads on Kubernetes. And yeah.
Yeah. And on top of that, I think one thing you'll agree, right? Most of the time, what we do, we check for application and we decide on a number of certain RAM, certain CPU, and then we just lock into that. We never
True.
observe like whether it's correct for every 24 hours timeline. Maybe your application might behave oddly when the scale is less, and when the number of requests is receiving very less. Maybe at evening time it does not need that much resources. Maybe morning time it needs. So that's what actually happens in real life, right?
True.
So manually, what I have seen, like at any production level cluster, is really impossible to manage because of the dynamic nature of request every time that we receive, right?
Yeah. Kunal, can we also talk a little about bin packing and like few of the terms that we have used here? Because if someone who's a beginner is also joined the stream, they might not have much context on those things, right? So can you
Definitely.
talk a little about bin packing, like how what it is and how does it work?
Yeah. So it's very easy to visualize view. So suppose I have three different nodes, right? And consider that these three nodes are running in a same cluster. First node have one or two pods. Second node also have two pods, and last one is empty.
Mhm.
Now, if a new pod gets scheduled, like I deploy something, a new pod gets scheduled, that single replica. By default, Kubernetes is built for high reliability, so it will push the pod into the empty node, right? Because that makes it highly available.
Mhm.
And that too, if you see, ideally, what common sense, like if you and me and designing manually, what we will do first, we'll check if node one is completely full, then we'll push it to node two.
Mhm.
Then if we push it to, because the nodes are expensive, and if you're using GPU based node, that is very expensive.
Mhm.
So bin packing is an algorithm. What it does is it decides like which pod to place in which node, to make sure that we are using the less number of node. Actually, I can say we are using least number of node, and we're making sure that we are not leaving our node under optimized.
Mhm.
So we are not using the full capacity of node, or neither we are putting too much workload in a node, so that it is overutilized, like it
Mhm.
is getting out of hand. So by doing that, we bin pack. That's why it called bin packing algorithm. Bin pack pod into single nodes to maximize utilization.
Yeah.
That's what we do.
So that seems like a lot of manual work, and even if it is taken care by
Yeah,
an automation, it is a lot.
Yeah, and think about the scenario, like basically it's an algorithm, right? The number of node as it increases,
Mm-hmm.
the time to execute the decision making, it also becomes complex. Like so,
Mm.
1, 2, 3 node is easier to decide in this 3 node which where it place. But if the node number is 500, 600, then it becomes very difficult, like
Yes.
which node to choose and which node to which node that data should be moved, all those decisions. So that's what
Mm-hmm.
it's a called bin packing algorithm, and it's a industry level term. I think nowadays, like everyone is following one way or another to bin pack pods.
Mm-hmm.
That way, you are essentially making sure that okay, I'm good. Like I know my nodes are properly optimized.
Yep.
So that's what it is. And last point that I mentioned, like set the right request to fight CloudOS while maintaining performance. So what do I mean that if you deploy any workload and you set like okay this workload I've said like 5 GB, okay, or 2 GB of per pod and maybe 200 millicores of CPU. But you might not know that that pod, the workload might be might run fine in a lesser number of CPU, lesser number of RAM, and it might need some extra CPU sometime. So we observe that workload for you, and if something is there, we right size it rather than changing your YAML. In the spec, we modify it and we reduce it, or sometime we like increase the size of it directly. So that way, your workload is also properly right size, your node is also properly right size. So overall the graph that I was showing before, uh, just a minute. So overall the graph that I was showing before, like this is before optimization, the blue line is
Mm-hmm.
based on the when we optimize, what happens like the based on the resource uses, the node and workload starts up and down. So yeah, that's what it is. So
Okay.
now everyone will agree with this, that Kubernetes is efficient default. So there's a question for you guys. I think let me
Okay.
ask the
So yeah.
question. Yeah.
Okay. Yeah, there is a question on the screen. I believe you can see it. So this is only if someone has registered for it, right?
Yeah, yeah.
Yeah.
Whoever registers on
Yeah.
the
So you
webinar
would
can answer the
see, yeah,
question.
you would see a poll on the screen and it says what's your estimated CPU utilization in your current Kubernetes cluster. Like doesn't matter if you are
Yeah.
running a POC environment, doesn't matter if this is your production environment, like whatever Kubernetes cluster you are using, based on your estimate and based on what you have seen normally, like what do you think the utilization ranges from? So select one answer and then the results will surprise you.
Yeah, and by the time they are like answering, I can answer certain question. So one guy asked, Saik asked the question like curious, how does CastAI work differently from the automatic cluster features in Carpenter when you are using AKS or EKS? And the built-in automatic cluster in EKS, AKS offers cost optimization benefits for your Kubernetes workload. So definitely we're going to discuss all those stuffs in upcoming slides, Zach. And we does offer a lot more benefits if you are using Carpenter for EKS or AKS built-in feature. AKS does not have anything as similar to Carpenter, I guess. Some node auto provisioning is there, but I don't know what level of it has been developed yet. But yeah, definitely there are a lot more, into it, like what we do, and we're going to discuss all those stuffs.
Okay,
I think
72% voted. So I'm not sure if we should give one more minute or yeah, maybe let's end
yeah,
up the
yeah.
poll and show
Those
the results.
You can, like, if you have not registered and if you are still joining maybe from YouTube or from some other source, you can still, I was about to say you can still vote on the comment section, but yeah, here are the results.
so the result I will just announce it. People, if on other places they can't see. So the vote, it looks like less than 20% people voted for 20%, and some guys voted 20 to 40%. Majority have voted 20 to 40%, and second majority is 40 to 60%. So let me just reveal the result. So as per the latest, data point or survey, last year we got to know that average CPU utilization across different organizations just 10%. And memory utilization is also very less, is 23%. Now, if you think about that, like, so CPU utilization 10%, what does that mean is we are paying for our CPU and only utilizing 10% of it. If it's your on-prem CPU, still it might not hurt, but when you're working on any cloud platform, just think about the thing that we are paying in bills every month and we are not using it. So that's what it is. And next, even though I am not little bit not that much worried about memory because it's still comparatively little bit cheaper than CPU, but frankly 10% is not a number. Like, it should be at least 60 to 70% to make sure, okay, what you are paying and what you are getting back, it's same, right?
Yeah. And maybe Kunal, I think are we sharing slides or recordings after the session? Yeah, recording will be live because it's streaming on YouTube. So whoever joined late or whoever want to like revisit, you can check the recording on the YouTube. But are we sharing the slides as well?
Yeah, we'll share, not a problem.
Okay, sounds good. Then we'll share the slides as well. If you wanna learn more about that, there'll be some links as well. Like, for example, the source of this survey, like where did it come from and everything. So we'll share the slides afterwards as well.
Yeah, definitely.
Okay.
And I think Anil asked a good question. Like, maybe I'll just take it before moving forward. He
Sure.
asked, like, I have a cluster running on VM where developers will schedule without limit and request. In this case, how CastAI will optimize and schedule? So that is a very good question, Anil. And exactly for this kind of use cases, CastAI can really help. So if you are using CastAI, you do not have to worry about whether I set the right number request, right, limits, because CastAI is not a declarative; it's like a proactive in nature. So if it checks, okay, whether you set it right or wrong does not matter. It checks the app workload, it checks the pod. If it's wrongly assigned or if it's using too much CPU than it should be, it will underutilize, it will change the spec so the pod gets synced in size. And if it's like underutilized, the workload is struggling to do it, it will increase it. So automatically it does the thing for you. You don't have to worry about it, or your developers does not need to know that what particular memory or CPU is exactly good for me. I think I'll just go to next slide. So now coming to the main topic, and guys, like, I think people are commenting a lot, so please feel free to drop quick Q&A. Even if we can't answer, I'll personally reach out to you after this webinar and get back to you. So question is, what does container live migration means? So by definition, it's the ability to move pods in same cluster between nodes without interruption and without any restart. Now, again, I'm just repeating myself. You have a pod that is running on node A. You want to move the pod into node B. So generally what we do, we just kill the pod and create another one in node B. But in some sensitive workload where you can't kill the pod, or there's some batch processes going on, you have a stateful pod that if you kill it, the process will be gone and will restart again. In those scenario, what you can do by using container live migration, you move the pod at the same state what it is in and move into another node. And what essentially it will happen, the process that is running in the node pod while it was in node A will continue in node B. The TCP tech stack, TCP stack, remains intact. Everything remains as it is, IP and everything, and your pod resumes for node B rather than starting again. So that's what it is at its core. So when I discuss about the problems, why we need live migration and all. So there are a few things. So firstly, stateful workload that we have, right? That those can't be stopped, those can't be restarted. Because any stateful application, if you kill it, you'll have certain data loss or certain interruption of services because it's not built for microservice architecture, but still we are using it.
Can we, Kunal,
Secondly,
sorry to interrupt you. Can we
no problem.
give a real-time example of a stateful workload? like so that everyone could know the context?
Yeah, definitely. So let me just think about something. Okay, so this is a nice example. Suppose nowadays everyone is training one model or another in their GPUs, right?
Hmm.
Now, think about a scenario where you are batch processing some job, maybe a Python script, you are doing something, and it takes maybe 8 hours, 7 hours, 9 hours to finish processing all the job. Maybe you're converting some images, maybe you're doing some other stuffs. And in this scenario, what can be done is, suppose you have processed 500 images, right? And you are storing it, you are processing. Once the whole thing is done, you will save it somewhat. That's the similar job. In this scenario, suddenly what happens, like if the pod gets killed, okay, pod is intact, is fine. You are continuing, maybe it takes, suppose it takes 1 hour. Within 1 hour, the whole process will complete, and then you will save the file, write file using Python into some other location. But in between, if it interrupts, right, what will end up happening? You lost the compression that you are doing for last few minutes, and you have to start again. So that's what I am saying. If I give a real life example, for instance, suppose you are maybe generating a video, or doing all the stuffs, which is very resource heavy, and something, it needs to be active for a certain number of time. Maybe I can give you another example. So sometime if you see when you make payments, okay, online, and in those scenarios, these kind of are very sensitive, data is getting traveled, you are paying, and that API needs to check whether payment has been done successfully. In this between the time, the pod needs to activate. So suppose while you are making the initiating the payment, if the pod gets killed, suppose you are doing it in Kubernetes environment, if the pod gets killed, or definitely there are some certain layer to it, like we have multiple APIs to check response time or whatnot. But maybe in between, if it gets killed, what's end up happening, like sometime it stucks, right? Like this one end does not know whether it has been paused, and this one knows, but there's no connection between it, and then it restarts again. So in this scenario, when rather than killing the pod and creating a new one which does not have any idea what has happened past few times, few minutes in those its other replica, rather than that, if you move it, then that solves a lot of problem.
Yep. Thank you.
So
Yeah.
yeah, so that's what it is like.
There are actually, Kunal, there are more questions, but I most of those are for the slides, because some of the concepts you'll be explaining later on. So I'm not taking the question, but if you feel like we need to take any questions right now, feel free to pick. But otherwise, we can take it later on as well.
Yeah, I think we have a couple of slides, and maybe at
Sure.
last we'll,
Sure.
after we explain, we'll take some.
Yeah. Yeah.
So I'll just next slide. What we'll do is very simple. I'll discuss about the solutions that happen. So as I was talking, me and Piyush, like how that can uh, help us to, like how live migration can help us to move statelet, move one pod into another node and resume the operation. So by doing this, your application runs on some SLAs, right? You are guaranteeing uptime, first of all. Secondly, so what I was talking at before, right? We are doing some bin packing algorithm. Now think about certain things, that when your pod is running on certain nodes and you can't kill it for a stateful application, then the bin packing is null and void, because you can't move the, if you restart it, like you have to move it to another node, because this node is already bulky, or this node is underutilized. You can't do all those stuff. So to solve this problem, the CLM was actually born. And another thing is, suppose a very old application, maybe a old Java-based application you have deployed, and now you are seeing that, okay, my performance is, it does not need that much RAM, that much CPU, that much memory. So what you can do, you can't right size it, because the moment you right size it will get killed. So now we can do it by doing live migration. We can right size it automatically. So, and also, this is last point is the most important one. Now, suppose you have a production workload, and now you can't run that on a spot. People will say the spot gets killed in 40 seconds, 30 seconds time. and we lose our production timeline. But if you are using something like CLM, you get the notification that my node will get evicted. It's a spot evict. Then you can directly move that to an on-demand machine. That's what actually we do at our core. If we receive the signal that this spot machine is going to be unavailable, then we move it to an on-demand machine. But 90% of the time when the spot is available, you're still using that 90% discount from your cloud provider. So that way, basically there is a non-interruption service, and where you can use it essentially without hampering your uptime. So yeah, I think yeah, Piyush.
Yeah, I was just saying, yeah, maybe we can just explain it, and then I'll we can take one question after this.
Okay. So next I'll just explain like how does it work with a very dumb animation to dumb it down a little bit more. So same thing, like I have two nodes. First, I have a pod, and the IP you guys have to note is 100.15, right? Just as simple as that. Now, I send an event that this pod need to be moved to this node, whatever may have happened in the node A, and then the migration starts. The pod name might change, so you see it will name as clone1, but the IP remains same. So generally what happens when you move any pod or create a new pod, it gets the IP from a pool. In AWS, it's from a pool, or Azure from a pool. But in this case, it will retain the old IP. Migration will complete. And then once that's done, it will inform the migration event that, okay, migration has been done. So that's as simple as that, I guess.
Okay,
Yeah, I think
that's cool. Can we
yeah.
take this question? You can see it on the screen, right?
Which one? No, I can't.
No,
But
okay. So the question is, it's Dharma asked this question. If we have multi-cloud environment, how easy it is for CastAI to maintain consistent policies and governance across providers?
Okay, so that's a different question from today's topic, but I'll answer it. So multi-cloud environments is definitely a good way to avoid this AWS downtime, as your downtime that has happened in the season that is going on. So in multi-cloud environment, CastAI is not a policy governance provider, but what we can do, you can connect all those different cluster with CastAI, and in a single dashboard, you can visualize different cluster that you have across different cloud providers, different region. And I think we can say announce that it's already released, like something called Omni. Now, what that does is basically you can have your cluster connected with nodes from different cloud providers. It may sound scary, but okay, I'll just explain it. So you have a cluster maybe in AWS, and nodes can be from different region of AWS as well as different region of other cloud providers, and all can be connected and work coherently. So that you can, I think there is no other solution right now which can do that, and that makes sure infrastructure a highly reliable system as well as a very resilient fault tolerant system. So yeah, that can be done, Dharma, to answer
Okay,
your question.
awesome.
I think other question, yeah, and
Yeah.
I said thanks. And Rahul's question, I just wanted to see if in node B of the pod have same IP as node A, will it affect the migration? No. So we do it very smoothly. So what do I mean very smoothly is the moment we create a new pod, and the moment you kill the other one, the switchover time is very less. It's very seamless, as seamless as that your packet drop will not happen. And the moment it gets killed, and we'll have the new IP here. So the why people might ask why we need the same IP. We can use the gateway API to use labels and selectors, right? The reason we are using same IP to keep your connection, TCP connection, which works on layer 3 intact, and that way you are not losing any packet drops.
Okay, guys, if you also have any questions, let us know in the comment. We'll try to take the question if it is relevant to the slide. If not, we can take it as well. So I think Rahul got the answer. Thanks for answering that. We can move forward now, I think.
Yep. Okay. So now you guys might ask like how we're doing this. So that's why I'll just spill up the secrets. So first, what happens is we run a demonstrate on all the nodes where you need to have, the migration possible. So the source and the uh, destination as well. So this demonstrate has something, a controller. That controller, what it does, it essentially makes sure that okay, my node is ready for the migration to happen. And secondly, it can inform the controller, okay, the migration is completed, all the stuffs. And lastly, we're using something called queue. So that full form is checkpoint restored in user space. That actually takes the process back up and everything, and that restores into the destination pod. And now to handle the TCP connection and IP thing, so we have forked AWS CNI and we done our own version of it that will run on the cluster, and that will make sure that rather than taking any random IP, it is taking the IP from the last pod that's getting deleted. So that's how essentially you are making sure that you are getting same IP and you are handling the traffic without any downtime. So yeah, that's how the whole thing happens without any interruption, without downtime, and we move it pod without any restart as well.
Kunal, we have a question. How
Mm,
does live migration integrate with existing auto scaling and scheduling? Like, will it impact anything, or do we have to, like, let's say, shut down anything to make sure the cast
no,
AI
no,
does it work?
no. It works simultaneously. Actually, Piyush, there is no impact. So if you have some auto scaling rule, if you have some scheduling rule, it will work as it is. On top of that, yeah, if you want to make sure that this pod that should not get killed, it should be migrated.
Mm-hmm.
You can just add it like so.
Okay,
Most
awesome.
of the work, see, suppose if your workload can be killed or something, you don't need it. To
Okay.
be very
Okay.
honest,
So we
but
don't
if
need to
you have
make
some,
any existing changes to the cluster configuration or
no,
anything. It just sits on top of your existing autoscalers and everything.
existing, yes.
Okay. Cool.
Yeah, if you have maybe not a autoscaler, if you have something like event-driven autoscaling like 𝗓𝗲,
Mhm.
all those stuffs, it can work with that also without
Mhm.
any
Mhm.
um, problems.
Okay.
So
There is
there are certain use cases.
Yeah,
Yeah,
there
yeah,
is
go
another
ahead.
question. If we can just take this quickly and then we can move. So while migrating,
Yeah.
how the pod was getting the same IP?
I think that's a nice question. So while migrating, how we're getting is because we're using a forked version of AWS CNI. So AWS CNI is, as you are guys aware, like it's available for everyone. Now we have forked it and we have added some features into it. So what happens when you create a new pod into EKS cluster, it gets a random IP from the pool of it.
Mm.
But rather than that, what we are doing, we're making sure that controller sends the IP of the pod that is getting killed, and when the new pod is getting created, it just takes over the IP from the previous one.
Okay,
That's how it is.
awesome.
Yeah, I think a lot of questions, and please feel free to drop whatever the question you have. It really helps us to understand. And there are a lot of use cases. So suppose you can migrate the state instead of restarting the pod, and you can run any application which is not built for it, but still if it's run on spot, you can run it on spot, and don't worry about like it's getting killed because you can just migrate it. And there are a lot of old Java application, all those things you can do it. And because you can move pod without worrying about whether I lose the pod state, you can just bin back it further, without having any issue. So
Okay. And Kunal, can we talk a little about what do we mean by migrating the state instead of restarting the pod? So what actually
yeah,
are we doing?
so that's very simple, Piyush. So if I ask you, you deploy a new workload, right?
Mm-hmm.
And then you think that okay, my workload is not behaving properly. I need to means suppose on single node it is not working. You create another larger node and you make sure that okay, my all my pods need to be moved to larger node. So what you'll do? You will just drain the node, right? First node you'll code on it and you'll drain it and then you move it. But that what happens basically for single second of time, so maybe for some time your pod will get killed, and it will create it again. That's why I mean by restarting it. So it will killed and it will get created again in another other node. So rather than that, we're just migrating it. And migrating a state means basically if the pod is having some state and it is processing some task, it is working on something, it will still continue to do that into when it's get created into a new node. That's what state migration is.
Awesome.
Yeah. And I think there are some other questions.
Yeah, maybe we can take this one. So Vaishnavi is asking, in which specific scenario would you recommend not using CastAI live migration?
Okay. Definitely. See, if your application is fully fault tolerant and you have built it in a modular way from scratch, okay, like you have written a very modular approach, like if your pod gets killed, still another replica will serve it. All the stuffs, if you have done it, then you do not need it. But most often than not, what we do, we have an application and we just need scaling. We just package it into a Docker file and we deploy into cluster. Maybe like I can ask you this question as well. Like, how many time have you seen like when any team goes for a Kubernetes cluster, they do ideally what should happen? They have to again go for the development phase, right? They have to think about the microservice thought process, break their code also in multiple steps, then redesign everything.
Yep.
And the easiest way is you have an application, you package into Docker and deploy it. Like what do you think? Like in your experience, like have you seen the first thing happening very often or not?
Sorry, I didn't get your question. First thing happening as in?
Yeah. So see, there are two ways you can go microservice, right? So you have an application, you Dockerize it and you deploy it into Kubernetes. Second thing is you think about the microservice thought process. You break down your code into multiple modular things like backend into 4 backend, frontend into 5 frontend. You break it down, you redevelop, go for the redevelopment phase with the developers, and then you start going the microservice thing. Like have you seen that happening? I have not, to be honest. Like, have you seen?
No, not really much. Yeah, I agree with you on that.
Yeah, so that's the ideal scenario, like ideal world which should actually redevelop application and then actually we go ahead and deploy into Kubernetes. But most often than not, what we do, have an application is Dockerize it and deploy it. In these use cases, you should use something like CLM when the state matters a lot. But your application is very fault tolerant. If you are running 10 replicas, you kill 5, still your application will be running fine. In those cases, you might not need it. Yeah, to answer your question.
Okay, cool. Thanks for answering that. Vaishnavi, I hope you got the answer. Is this okay? So there is another question. Yeah. Is this related to blue-green deployment? How different this is from blue-green deployment?
Nice question. So blue-green deployment is a very, kind of very high available deployment strategy where we have 2 replicas of the same thing. And if one goes down, you still have another one. And essentially what we do, update the first one. And then, once that updated, we test it, and then we, do a changeover. So the second one becomes old version. Then you start update second version. And that way you have a 2 version of it, blue and green. Now, how CLM is different is that we're not using 2 versions of the same application because it's very, very costly. So if you think about a production get workload, it's very costly to run 2 applications in active or active passive situation. Rather than that, what we are saying, like if the need comes, you have to kill one application, one node. In those scenarios, you are moving the pod from one node to another. I'm not saying I'll run 2 same pod and into 2 node, and if this goes down, this will be active. Not like that. If this node have to get down, then we'll move it. And another thing is, like even if I run 2 replicas, we might never know in a stateful application if this is processing a job, this will get reflected in my second pod, right? Because those are acting as a separate replicas. So if this one is maybe processing a job, it's stuck on 50%, and that time you kill it, this pod will not know that this other pod has done already 50% of the job. So in CLM, what we are doing, if this is stuck on 50%, and now this node has to be killed, this will this I migrate to this one, and in my new system it will start from 51%. So that's how it is.
And I think, Kunal, it's good to add over here, like when we do blue green deployment, like we make a switch, right, from blue to green or green to blue. So even though it's a blue green, but it's not really like 100% zero downtime. There will be some downtime while the switch is happening, right?
Some
When
downtime.
we are doing the failover from one replica to another or from one region to another. But with Cast
Yeah,
AI,
yeah.
like because I have seen it personally, and we're gonna show it to everyone as well. Like when we do the live migration um, of a Minecraft server, what happens exactly? So the thing will be more clear, like how it is different from the blue green deployment.
Yeah, yeah, definitely. So I'll just move to next slide actually. So we
Okay.
can, as you mentioned, we can just go ahead and start demoing the. So guys who are like joining, like feel free to just scan the QR code. I'll just keep it for some more time.
Yeah, it's time for the live migration of the Minecraft server. So if you can see the
Yeah, yeah,
QR code on the screen, you can just scan it and join live with us over there.
yeah. So I'll just explain how you have to do it. So click on connect to server, select the server, okay, and the game will just load for you, and you can start playing. So you see, right now I'm playing it. So
Okay,
some
so
guys has joined.
yeah, so let us know everyone if you are able to log into the game and if you are able to see this screen, and if you're facing any issue, let us know as well.
Yeah, I think three guys has joined already.
Okay.
So I'll just wait for 2 minutes.
Hmm. Meanwhile, we can maybe take a couple of questions while everyone is joining.
Yeah,
Like have
someone
an
killed.
idea. I have an idea. You could just, increase, zoom in a little bit the screen for a while, and False will see the QR code directly on the screen. It's the same one. Yeah, just
Yeah,
zoom in a little bit to your screen. Yeah,
Yeah.
that's perfect.
people keep killing me, so that's fine. So you can join from your mobile phone also, not a problem. Just scan the code, and you're free to load it onto your browser, and
Okay.
that's how it is.
Can we take this question meanwhile, Kunal? So Arnab
Yeah,
is
yeah.
asking, will the migration strategies differ for stateless versus stateful workload? Would there be any difference?
See, it will work in both the places, but stateless you might not need the migration, but
Mhm.
stateful definitely you
Yeah.
can do it, not a problem. And stateless also, if you want to do it, like certain things, like you are free to do. It's just as simple as that. I'll just show you how it works,
Yeah.
and maybe in some other time we'll demo it with different kind of apps and whatnot. But there's no different at all. It just
Okay.
works.
Awesome. So,
I
I
think
mean,
last web
even
that
if they are using stateless or stateful, there is nothing extra that they do, right? So it's one
no,
and the
nothing.
same thing. The process is okay. Cool.
I think just zoom it out a bit now. Uh,
Mm-hmm.
so I think what I'm gonna show you is very simple. So as I was joining, right, I was clicking the Kubernetes server. Now, if you see, this is the Kubernetes server, right? This is the pod which is the running the game, and 12 users is right now connected with this particular pod, and they are playing it a multiplayer level. So I'll just respawn it for just sake of it. And now everyone is moving around, playing the game fine. And this is my IP 192 168.32.39.215, and this game is running fine, and this is running on node 60.203 in EKS. This is my EKS server, and here I have like added a graphical representation. So this shows like it is running on this spot. Now I'll just click on another node, and once I click on that, uh, okay. So if you see, there's another. Just let me connect again. something I think gone really wrong. Just a minute.
Maybe let's try. Yeah, this one, multiplayer.
Yeah. I think that one I was running on single player, that's why it could not take that load.
Yeah,
But yeah,
yeah.
Someone is
guys,
also saying that they are getting socket error. Is there anything that they need to do?
Just scan the, no. Actually, we're running in the single player version.
Okay.
That's why people join. So just do one thing: scan this QR code, and it will show that player numbers, and I think it will be free to do.
Okay. Okay, so please,
anyone
like whoever joined the server earlier, you can try again.
Yeah, join this one.
I can also do that.
And same process, just connect to server, click on the server name, and you're free to do it. So and I see there are 9 players already playing the game. Yeah, so all those players are playing right now, okay, and 12 players are playing fine, and they are separated in different teams. And same thing, it is running on this server is running on pod IP 170, and is the world bad? I think someone commented. That does not matter, like we'll figure it out later. So the world generates auto randomly. So right now it's some watery situation, like unless you're expert Minecraft you can't play. But nevertheless, what I wanted to show you guys, if you see now it is running on this node. So what I'll quickly do, I'll click on another node, and hopefully what should happen, like it should start migrating into another node. So I clicked on the second node, and here I can see online players, like 21 players are connected. They are playing the game, and it has migrated to one node to another, and none of the player has got out from the game. Here I can see the active status, people are playing, someone died, someone is killing, everything. And I can just click again into another node in this situation. And if you see, the previous IP was 170. Now this new node came, 𝗀𝗁36. Both are having the same IP, and the migration is successfully done. So in this kind of scenario, when multiple players are playing, think about a thing: if I just kill this pod, and then if I start again, it does not make sense. This 22 player will lose the state, and they will not be able to continue playing or enjoy the game. I can just do something called auto move. What that will do, that will constantly start moving pod between different node cycle through every 10 second, 20 second, and not for a single time. Like the state will not persist, or people will get the disconnection alert and all. So right now, see, I have used like move the pod from this node to second node, and now again it goes back to the first node. So the node keeps changing very fast, but people are playing the game. 22 players are connected. Again, if I click here and go back to the node, still I am able to play. So that's what I wanted to share with you guys.
This is so cool. So let us know, guys, if you have seen any migration like this ever, in which you are moving your pods actually from one node to another, and there is not even a slightest lag in the session that you are on. So, and I really like the idea of using a Minecraft server game so that we can check the session as well as if anyone is getting any lag while the migration is happening. And I felt it was seamless. I just checked on my phone as well. It was pretty straightforward and seamless. So that's really cool.
Just to make sure, like we started from clone number 30, now it's like 39. So we have already migrated 10 times, and none of the players have raised the question that they have any lag or any downtime. So that's what it is at its core. So I'll just reset it now. Okay, back to our slide. enough game.
Okay, guys, game time over.
So what?
Let's get back.
So what's available right now?
We have
It
more
works
games.
flawlessly. Yeah, we have more games. Definitely, we have quiz and we have nice prizes.
Oh yeah,
And
we
so
still have surprises. Yes, I'm sure everyone will wait for that
yeah,
as well.
I think we're getting great compliment. This is awesome, smooth for me. Everyone, like no one got dropped.
Yeah.
That's a good thing. Demo God is with us right now.
And
So
this
EK
is
is right
something
now
that,
available.
yeah, this is new and thing that don't often see in the demos, right? So when you showed me the demo first time, I was amazed, like, how is this even possible? Like, this is something that
Yeah.
everyone, whoever has worked with Kubernetes at least, would find it little surprising and exciting. Like, this is great.
It feels unreal, to be honest.
Yeah.
Like it should not have been happening. Like why it's still running like without downtime? But yeah, surreal things. But it's now available on EK. So if you have a AWS cluster, you can just install CLM using a Helm chart and give it a shot. It's very easy to do it. GK you are releasing very soon. It's almost like I have tested myself. It's working fine. We're just polishing it a little bit, and as you, it will come on next year. So that's about the update. And now we have something quiz time. So let me just.
We'll launch the quiz.
So I had some issues with my
Yeah.
microphone, like people are complaining there's a lot of static coming. So I have switched to my MacBook microphone. Is it my audio is coming okay? Or there is a lot of echo?
Yeah, it's fine. It's fine.
Okay,
No, it's
awesome.
fine. I can hear too.
Awesome.
Plain and simple.
Yeah, let's Kunal, let's get back to PPT. Where's the QR code for folks to join?
Yeah, I'll just wait it here. Like, feel free to join, man. I'll just wait 2 minutes until everyone
Okay.
joins.
Meanwhile, if anyone has any question about the migration that we just did, yeah, feel free to let us know.
You can take some questions here. Did you mention you have forked for AWS CNI code thing that updated the logic based on your needs, like you get same IP. Once migration of the pod to new pod, then the old one is deleted because the two different pod has not same IP, right? But the new pod will start work from the old one. Leave it. Correct, exactly. So we'll take the IP from the old pod and it will continue as usual. When a live migration fails halfway, storage attached delay, what is the exact rollback behavior and how do you guarantee no split brain or double writer scenario? It will not happen. So that's why, we dedicatedly put a controller and as a demonstrate in every node to make sure unless the migration is successfully done, we will not kill the whole pod. So the moment migration is successful, that controller makes, it checks all the states, all the TCP IP, everything. Then it simultaneously it moves the pod from one node to another.
Kunal, how would it work in case of like a pod is running for, let's say, a database like a PostgreSQL, or a database pod is running? Would it work
It
seamlessly
works.
for that?
It works very well. Actually, that's another use case. It works very nicely. I have tested myself. So if you have a database, that is also a stateful workload, right? You can't, just kill the database
Yeah.
and create another one.
Yeah.
In those cases, also this works fine without any issue.
Okay, awesome.
I think I can just now go back to the quiz now.
Sure.
So
We have
77
77 folks. Yep, so we are good to kick off,
Yep.
I believe.
So first finger first gets a higher point, just to say. I'll just maybe I think I can give 2 more minutes. And Like I'll just wait for some time. If you haven't joined, like feel free to join. Another person asked the question. Have you mentioned earlier that CastAI is not just observability, it will give recommendation and do it right? Then what is the difference between VPA and CastAI suggestions? CastAI is not just no, it's not just observability, it gives recommendation as well. What is the difference between VPA and CastAI suggestion? Is VPA, I believe you are talking about virtual pod auto scaling and CastAI session. Both can be implemented simultaneously, but what I will say, like VPA based on your predefined requirement it works, while CastAI checks on your current user based on request, not based on the limit and request that you said before. So it's based on the
Also,
so I'll
I
start
would
the quiz now.
suggest, so recently, like around a couple of months back, I published a detailed video on my channel around the CastAI demo. So you can go through that.
You
So
can
we did not cover live migration on that because we were supposed to do this webinar. But then other than that, related to cost optimization, around all the recommendations that it provides, every feature is explained in detail on that video. So go check that out, and yeah, it will be helpful.
so I think here guys are very knowledgeable about Kubernetes. So let's see the leaderboard.
Okay. 𝗵𝗲_𝗀𝗃 is leading with 963 points. Cool. Next question, guys. It's over here.
What is the minimum Kubernetes version required for Lime? It was actually present in the PPT, but I somehow skipped it. I think YouTube, whoever watching YouTube, they can just go back and see it. I think that's cheating for them. Let's see.
1.30.
So it works as old as 1.30 version, and before that, I think hardly anyone uses anymore. But yeah, it works from 1.30.
Okay. Third question.
Which Kubernetes workload type is not supported by container
I
live
think we have
migration?
covered this, right?
And within common sense also you can answer, like just to give you an hint,
Yeah.
some kind of workload should not be migrated and does not make sense to migrate. You can decide based on the options. Jobs we can migrate, man. So the answer is daemon set because it's by default already present on all the nodes. So what we will do with migration? So you have new winners, I guess, or not?
Yes, Vivek, Videsh, Amarnath.
Vivek Singh. Vivek is no.
No.
Vinay is leading.
Okay.
Vivek dropped. So second last question. Just start it. What is required for successful migration between different instance types?
Oh, that was closed call for 3 of the answers.
Yeah, 16. So the reason, I'll just take 1 minute. So the reason it needs to be from same generation family because we are moving processes, right? And you guys know that CPU architecture, if it changes, the process might not work into another generation of VM. So to make sure the process works, that's why you need same generation of
I have a
VM.
question over here, Kunal. Okay, maybe after the quiz.
Yeah.
We'll take after the quiz. It's fine.
Okay. Last question, guys. Which of the following is not a core capability of CastAI platform? Cost monitoring, workload autoscaling, container image building, and Kubernetes security monitoring.
That sounds about right.
We got it rightly. Let's see the final leaderboard.
Yes. Okay.
Okay, Tarun Agarwal is our friend. Prithvi is the winner. So, Vidudas, what do we do with Prithvi
Congrats.
now?
Yeah, so please take the screenshot of your, like the game, the screen, the name, and please email us, like either Kunal or me. I'm dropping our emails into the chat, and so one of us will reach out to you. Yeah, we'll agree about the details how we'll ship AirPods Pro free, and two other places like the second and the third. Please also take the screenshots of your name at the game and email us. We'll send you some
So I believe
real nice gillettes.
second one is Saint Elmo, and the third is Dhruva.
Yeah.
So congratulations to
Dhruva,
you
yeah.
guys as well.
Fourth one is Tarun. Just wanted to mention, like, he's a CastAI expert. You can say every CastAI quiz he came first, like almost 3 or 4, I remember correctly. So nice to see them here. And yeah, I think Piyush, you have some questions, right? I think I'll
Yes, so the
stop
question
sharing.
that I had, it's about the same, like the fourth question that you had over here, right? Like the live migrations work effectively when the instances are of same machine family or same machine generation, right? So how does it make sure,
Yeah.
like, do we have any check in place in CastAI controller, or how does it make sure, or does it prompt us like, yeah, this is, it has to be?
Yeah, so basically, that's why we have the controller in place, to avoid all these scenarios,
Okay.
where we are, maybe sometime we just migrate and it does not work. So that's why we have something that will, check if my destination node is capable of moving it. If it's capable, then only it will move it. Otherwise, it will not.
Okay.
And the reason being, like, if we migrate and then it does not work, does not make any sense. That's why you have a daemon set and it works. And so this QR code in my screen is basically for a conference that we are doing on March 14 next year. And it is a large conference that will happen in Bangalore. So if any one of you are interested in joining, so you can just go ahead and register. So a lot more good stuff's gonna happen. We'll announce a lot more good stuffs on it. So yeah, I think there were some nice questions that we received today, and
yeah, it was fun, and I
so
hope
far I think
everyone
we're at the
had
end of.
a lovely experience. Before we summarize or conclude the call, do we have any more questions that we can take? Or I think we are almost at the time. Oh, I think we are good.
Have you checked YouTube? Do you have any question on YouTube also?
No, I'm checking, like I have a panel in which all the questions from YouTube and LinkedIn's are coming at the same place. So,
Okay.
I think we have, either we have covered it during the slides, or we have taken the questions, but let me have just a quick look at it. Okay, so there is this question. What will be the impact on our cluster when there is downtime on CastAI? Because CastAI is sitting on top of our cluster, right?
I'll not boast about it, but firstly, all the downtime that has gone with GCP, Azure, and AWS, CastAI was not down for a minute. Okay, so not boasting about it, but still, definitely we have multiple fault tolerant replicas and everything. So if your application is running, and CastAI will most probably run, but I I can't guarantee everything. But we have our enterprise SLA, everything fixed with you, so you get all these things. But definitely we have multiple replicas, multiple motherships, and also if one goes down, it will redirect to another one. And if everything goes down, what we can do, I just have to expect that. But it has never have happened in our experience so far.
Awesome. And then this another question, Arnav is asking, does the props like the Kubernetes liveness and readiness props impact the zero downtime pod migration? As zero downtime migration means traffic should never hit a pod that is not fully ready.
Yeah, so that's why I was saying about the controller, like we do not move the traffic from the first to second until the second is completely ready. So you have your probe, so readiness probe and all does not matter. You have liveness probe and that is working fine. And the moment we switch the transfer, we're making sure that the pod is ready to accept the traffic. Without that, we do not just randomly move it. So that is very easy to do actually. If you are, check CRIO how it works, it is actually very easy to randomly migrate a pod. That works fine. But the moment you make it a production ready, enterprise get ready, it becomes a little bit more tougher. That's what we do it. So that's why we have all those checks and controllers in place.
Okay, awesome. And Jagyan is asking, will the Minecraft server will be running without interruption? So looks like people will be using this for game streaming.
It will be. It will be. It will be. I have run as I think.
I think you
No interruption as such. Is it?
It's better now.
Wait, no, it's good. Like we had lost you for a couple of seconds, but now it's good.
No, so the Minecraft will keep on running. So I have, ran it as I as 150 participant playing that game, and I migrated 2-3 times. It was working fine. So there should not be any issue.
Yes, Nazir is asking, can we get the setup demo? For setup, Nazir, you can check out my channel. There'll be a video about Kubernetes cost optimization using CastAI. So it has the end-to-end detailed steps. You can go through that.
Yeah, and people who want to try it, I would suggest if you have a Dev cluster, just go ahead. There's a Helm chart is there. Just log into console.cast.ai, and you have a Helm chart. Just install it, just a one single command, and then it installs and you connect it, and then you can try also doing whatever workload. So I have done with multiple different kind of workload. You can migrate it yourself without any issue.
Okay, cool. I think we are good. I think we are good to close the call then.
Yeah, definitely. I think it was nice, Piyush. Thanks for
thank
giving us the
you
platform,
for
and
this
we'll collaborate in
opportunity.
future a
I
lot.
felt like everyone had a wonderful time. Everyone learned something new. Plus, they had fun. And congratulations to the winners as well. So thank you, Kunal and Vyotas, for joining us today. I wish we could do more sessions like this in the future. So for now, thank you everyone. Have a good day. Happy weekend. Bye bye.
Thank you. Bye.